Your next challenge is entitled Find the total number of digits the given number has. You are to create a function that takes a number as an argument and returns the amount of digits it has. See the examples below. With input 1, 2, 3, you return 3 because there are 3 digits in this number. 56 returns 2 because there's 2 digits, and so on. Clear enough? Let's go over to coding. Pause the video, solve the problem. If you get stuck, feel free to resume. Okay, so let's see, there's a couple ways you could go about this. I think I'm going to take a shortcut, take an easy way out here. So what I want to do is first, let's call it string num text equals number to string. And this nifty little function should take the number passed in and simply convert it to a string, like if you surrounded it by double quotes. So provided I have that, then it becomes pretty easy, right, to say how many digits are in there. It's the number of characters in the array when you think of a string as a character array. So I could return num text length. I think that should work. We would have a situation with negative numbers. I think you'd get one more character there. So we should add some protection for that. If num is greater than or equal to 0, this would be a positive number. Let's go and move that in there. And I think this works, and we're going to need this conversion to string regardless, so we can move that outside the if check. We need it either way. So if number is greater than or equal to 0, we got a positive. We're just going to simply return the num text length, and I think if it's negative, we should return num text dot length -1. And I did the -1 because I want to remove that leading minus symbol that denotes a negative number. I don't know if they'll provide negatives. Let's see, I don't. Test case 1, 6. So they don't even provide a negative number, and that's unfortunate. They should really do that. These tests are not very good. But anyway, that's my attempt to add some protection for that. Remember to consider all cases, and especially the oddball ones. So let's try this. Let's see if it can be this simple. Cool. Yeah, that toString was slick, wasn't it? Converts it right to a string for us, and we already know how to get the length of arrays, so problem solved. Now I'll do this I can show you another way of doing this with keeping with the integer. Let me refresh here. It's a little more roundabout. I think I would have just kept what I had there. But, you know, there are many ways to do things. Basically, what I'm going to do in this scenario is I'm thinking about dividing the number by 10 each time in a continual loop until we get down to 0. If you can think about how dividing by 10 works in our 10-based numbering system, it's almost like shifting the value. So if you think of just say for example the number 3,150. If I divide by 10, it goes to 315, right? That decimal place shifted left. If you do it again, it goes to 31.5. If you do it again, it goes to 3.15. You know, it kind of keeps shifting like that. With integer division, you're kind of throwing away the remainder, and that's fine in this case because I don't really care. I'm just trying to count digits. So I essentially do that until I reach 0, and then I'll maintain a counter and increment each time that I perform one of these divide by 10s. So that's sort of the idea. So if I hit int num digits equals 0 to start, right? And then we don't know how many iterations to do, right? Because this number could be anything within the valid ranges of integers. So I'm going to use a generic while loop. This is kind of like for, but you're not really telling it how many times to execute. It executes indefinitely while a condition is true, and that condition is what you put in the parentheses here. So I'm going to say while num is greater than 0. That's sort of where I exit out, is when I divide out and I hit that 0 from an integer divide where remainders are being thrown away. So let's take the num divide. We're going to do something a little bit different that you haven't seen. And just know this little shorthand, this is a convenience notation. This divide equals 10 probably looks very strange. It is assignment, and it's combining a division. It's the same as writing num equals num divided by 10. These are equivalent statements, and this is just a shorthand that you'll see. So you'll often see plus equals, minus equals, times equals. There's a bunch of them that you can do. So that shifts it, and each time I have one of these, I want to increment my counter. Num digits. Okay. And yeah, while the number is greater than 0, we have some, say, large number. It's going to get chopped down, essentially being shifted with each iteration until we're out. And at that point, once we're out of the while loop, let's return num digits. That's what they were looking for. And then the weird cases, I'm thinking, you know what we could do to be safe, to protect with negative input, we could say int value equals, remember how we had that absolute value method before? So we're creating a local value to work with. Ooh, value is highlighted. That in blue, that's making me, yeah, I think that is a keyword, so let's not do that. Int val, yeah, let's call it val. Doesn't really matter. These, I know I say naming variables is very important, but with really small scope temporary variables, it's completely fine to name them really short abbreviated names. So instead of using num itself, which could be negative, let's just pass val in, which I've already know has been corrected to be positive val, because I'm looking for this greater than 0. If I'm dividing negative numbers, I'm going to get negative numbers, so I think that should help. Val, let's see. And the other oddball case is if we have num passed in as 0. What if we receive 0? Then when we get down to when 0 is greater than 0, that never happens. So num digits never gets incremented, and we're stuck returning num digits equals 0. But the input 0 does in fact have one digit, the digit 0 itself, so this would be incorrect for that. So let's add a special case for this. If num equals 0, return 1. And that should protect us from that special input. I think we might be okay for the rest of this. Since we're using that absolute value class, I think we had to bring in the system namespace last time. And let's give this a go. Hey, there we go. Cool. So this is kind of cool, right? You're just staying with integers and just doing some simple math to figure out the number of digits. I think I like the other solution better, so I'll put that back in. The other thing I don't think we've done before is comments. So if you put double slashes in here, you can, anything you write after that on the line is commented out, meaning the compiler doesn't even see this. It doesn't run that code. So it's just for human notes. You can keep any kind of notes you want here. There is a practice in the industry where you don't want to be excessive with this. You want very meaningful comments that actually add value, not things that are extremely clear from the code itself. Like this is, I did this to help people who had never seen that before, but this comment is otherwise very unhelpful. It'd be very unhelpful for experienced programmers. But that's what it is, a comment. And then I believe you can do a multi-line if you combine with these asterisks. So I can say, hello world of SSD. You know, you can write a multi-line like that. That's nice if you have to write out a bunch of stuff. So, yeah, those are comments. Yeah, that's about it. That one gave you any trouble, feel free to hit me up with questions. Otherwise, thanks for watching.